Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0108, signifies a high voltage issue within the manifold absolute pressure (MAP) sensor circuit of the Honda Accord models from 2017 to 2023. The MAP sensor is a critical component that measures the pressure inside the intake manifold to determine the air density entering the engine. It helps the powertrain control module, PCM, calculate the appropriate air-fuel mixture for combustion. This diagnosis is essential because an erroneous MAP sensor reading can lead to poor engine performance and fuel efficiency. The issue is usually caused by a malfunctioning sensor, poor connections, or other wiring faults. Therefore, effective troubleshooting is crucial for restoring the sensor's functionality and ensuring optimal vehicle performance. The MAP sensor plays a vital role in monitoring the air pressure in the intake manifold, which directly affects engine performance and efficiency. Located typically near the throttle body, this sensor sends voltage signals to the PCM based on manifold pressure. In normal operating conditions, it should provide values close to or below 4.49 volts. By continually measuring the pressure, the sensor helps the PCM adjust the air-fuel mixture for optimal combustion. If the sensor outputs a voltage of 4.49 volts or higher, as indicated in DTC P0108, the PCM interprets this as a high voltage condition. This can affect vehicle performance, triggering warning lights and potentially limiting engine power. Understanding the role and proper functioning of this sensor is important for diagnosing related issues. Several factors can contribute to the triggering of DTC P0108. The primary suspect is often the MAP sensor itself, which can fail and send incorrect high-voltage signals to the PCM. This may arise from internal faults within the sensor. Additionally, poor connections or loose terminals at both the MAP sensor and the PCM can introduce intermittent voltage fluctuations, leading to errors. Other prevalent issues include damaged wiring in the MAP sensor circuit. The wiring may exhibit corrosion, cuts, or other physical damage, all of which can result in incorrect voltage readings. Understanding these potential causes is essential for an effective troubleshooting process and will guide technicians to pinpoint the exact issue swiftly. When DTC P0108 is present, several symptoms may manifest in your Honda Accord. One of the most noticeable signs is a significant decline in engine performance, which may include sluggish acceleration or unexpected stalling. The check engine light will likely illuminate on the dashboard, signaling an issue that requires attention. Drivers may also notice poorer fuel efficiency due to the incorrect air-fuel mixture caused by erroneous MAP sensor readings. Additionally, fluctuating engine RPMs may occur, particularly during idle or acceleration. Recognizing these symptoms early can lead to diagnostic checks, preventing further complications and ensuring smoother engine operation. The first step in troubleshooting DTC P0108 involves turning the vehicle to the on mode. This initial action is crucial as it powers the vehicle's electronic systems without starting the engine, allowing for diagnostics. Using the Honda Diagnostic System, HDS, measure the MAP sensor voltage. The expected voltage reading should be below 4.49 volts. If the current conditions fulfill the threshold criteria, you can move on to the next troubleshooting step. However, if the voltage reading is 4.49 volts or more, it indicates a possible intermittent fault. In such a case, examine the connections and terminals of both the MAP sensor and the PCM. Ensuring these components are secure and free from corrosion is essential before proceeding further. In this step, you'll need to first turn the vehicle to the off mode to ensure safety while working on the electrical components. After that, disconnect the map sensor's 3P connector. This action isolates the sensor from the PCM, allowing for more accurate testing. Using a jumper wire, connect terminals A and B of the map sensor connector. By applying this jumper, you can temporarily simulate the signal output from the sensor. After completing the jumper connection, turn the vehicle back to the on mode and again measure the map sensor voltage using the HDS. A voltage reading of 4.49 or higher indicates the sensor itself may need replacement. This helps narrow down whether the fault lies with the map sensor or other components in the circuit. Moving on to step 3 in the troubleshooting process, begin by turning the vehicle to the off mode to ensure that the vehicle's systems are not active while you're working. Once the vehicle is off, carefully remove the jumper wire that was used in the previous step. After this, turn the vehicle back to the on mode once more. Now, your objective is to measure the voltage between specific test points at the map sensor connector. This will provide an indication of the functionality of the SG1 line, which is integral to the map sensor operation. You should measure between test point 1 and test point 2 in the disconnected state. If the reading is approximately 5.0 volts, it confirms that the circuit is intact and moving to further diagnostics is warranted. If not, further investigation into the wiring integrity will be necessary. In this troubleshooting step, once again start with turning the vehicle to the off lock mode. This precaution is critical to ensure safety during electrical checks. Next, you will need to disconnect the PCM connector E, which houses multiple connection points essential for vehicle operations. After disconnecting this connector, check for continuity between two specific test points. The first test point is the map sensor connector's female terminal 1, and the second is pin 71 of the PCM connector E. A successful continuity test indicates that the SG1 wire is functioning properly. If continuity is present, you can then review any relevant service information regarding DTC responses, or consider substituting a known good PCM if issues persist. If no continuity is found, it means there's an open circuit in the SG1 wire that needs repairing. For this final step in the troubleshooting process, again start by ensuring that the vehicle is in off lock mode. After that, disconnect the same PCM connector E to isolate further diagnostics concerning the PB line. Just as before, you will now check for continuity, but this time between test point 2 of the map sensor connector, female terminal 2, and PCM connector E, pin 56. If continuity exists, the PB wire is functioning as intended, suggesting that the wiring between the PCM and the map sensor is in good condition. Just like previous troubleshooting processes, if continuity is confirmed, it may be worth reviewing service information for further insights or considering the replacement of the PCM if issues continue. On the contrary, if the continuity does not exist, it signals an open circuit in the PB wire that will need a repair. Once all necessary repairs and replacements have been made, it's crucial to conduct a final verification to ensure the issues associated with DTC P0108 have been resolved. Start this process by confirming the effectiveness of the repairs by rechecking the functionality of the map sensor. Using the HDS to monitor voltage readings will help verify that they remain within the normal operating range. Following this, you must reset the DTCs stored in the PCM to clear any fault codes. Once reset, it is advisable to take the vehicle for a test drive under various driving conditions to ensure that the fault does not reoccur. This step will help ascertain that the issue has been fully addressed, providing peace of mind that the vehicle is operating efficiently after the repair. The preventive maintenance is key to avoiding issues like DTC P0108 in the future. Regularly inspecting the map sensor and its electrical connections ensures any potential wear or corrosion is caught early. Additionally, consider performing periodic checks on the integrity of the related wiring harnesses. This proactive approach can mitigate issues before they escalate. It's also critical to use high-quality replacement parts when conducting repairs, as inferior components can lead to further complications. Establishing a routine maintenance schedule can assist in prolonging the lifespan of the sensor and its associated wiring, reducing the chances of future errors and ensuring optimal performance. In summary, the importance of understanding DTC P0108 cannot be overstated, as it provides essential insights into the performance of the map sensor in a Honda Accord. Effective troubleshooting steps, from verifying voltage readings to checking wiring integrity, play a critical role in diagnosing and resolving the underlying issues. Recognizing the symptoms associated with this DTC can lead to quicker diagnosis and repair, improving both vehicle performance and reliability. By implementing preventive measures such as regular inspections and using quality parts, drivers can minimize the risk of future occurrences of DTC P0108. Emphasizing the connection between proper maintenance and effective troubleshooting can lead to enhanced vehicle longevity and driving satisfaction. Please like and subscribe to the channel. See you next time.